here is example number 1C. We have a rectangular page that has to contain 24 square inches of print. So if you can see that I've labeled the print in the middle of the page X by Y, so the length is X, the width is Y, and I know that it needs to contain 24 square inches of print. So that's what I'm going to use as my secondary equation. So X times Y equals 24. It says certain things about the margins. On the top and the bottom have to be 1.5 inches. On the left and the right, the margins have to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? So least amount of paper means the area. And so for my primary equation, I know that I want to optimize the area of the paper. But in order to figure out the area of the paper, I need to figure out the dimensions of the whole page. If the width of the writing, the print, is Y, and each margin on the left and the right have to be 1 inch, can I call the width of the paper Y plus 2? Same type of thing with X. If the length is X, and the margins on the top and the bottom have to be 1.5 each, can I call the length of the paper X plus 3? So then to find the area of the paper, I would do Y plus 2 times Y plus 3. I want to optimize, I want to find the least amount of paper, so I want to optimize the area, okay? But right now, the area formula has too many variables. So I'm going to go back to my secondary equation, and I'm going to use it to solve for one of the variables. I'm just going to solve for Y. You could do it either way, you should still get the same answer. I'm going to go ahead and solve for Y. So then I'm going to take that Y value, and I'm going to plug that Y value into my primary equation for area. I'm going to go ahead and FOIL. 24x times x is 24. 24x times 3 is 72 over x. 2 times x is 2x, and 2 times 3 is 6. I'm going to combine like terms, so I end up getting 30 plus 2x plus 72 over x. Okay? If I want to optimize the area of the page, I want to find the minimal amount of paper being used, I need to first find the derivative of the area. So I'm going to find the derivative of my area. The derivative of 30 is 0. The derivative of 2x is 2. And if I want to find the derivative here of this 72 over x, can I bring this x up and make it an x to the negative 1? So then when I find the derivative, I get negative 72 x to the negative 2. So when I bring that back down, I get negative 72 over x squared. So this would be my derivative of my area. To find my critical points, I'm going to go ahead and plug in 0 for my derivative. I'm going to add the 72 over x squared to the other side. I'm going to cross multiply. Square root, and I get x equals plus or minus 6. Now we have to make sure that both of those answers work and make sense. If you're talking about length of a piece of paper, we can't have a negative. And so the only value I want to use is positive 6 inches for x. But now x, when we label it on our picture, didn't represent the length of the page. It only represented the length of the print. And so if I want to find the dimensions of the page, I need to do 6 plus 3 for my length of my page. And so the length of my page would end up actually being 9 inches. Okay. I still need to find the width of my page, so I need to find y. If I know that x is 6, can I go back to my primary equation, the x times y equals 24? If I know that x equals 6, can I use that then to solve for y? And I get y equals 4. But again, if y equals 4, that doesn't mean that that's the width of my page. That just means it's the width of my writing. So if I want to find the width of my page, I want to plug in the y plus 2. And so the width of my page is actually going to be 6 inches. So my dimensions of my page should be 9 inches by 6 inches. This is going to give me the least amount of paper used for my problem. Hope that helps. I'll see you after break.